Okay, I'm back, and you can see on the computer screen that there is a picture of some galaxies. And it says in the lab, you are given a view of the sky which contains a cluster of 10 galaxies. So here's like a galaxy, here's a galaxy, here's a galaxy, here's a galaxy. So these big things are the 10 different galaxies. It says to click on one of the galaxies. So I'm going to click on this yellow one here. And it says that it is galaxy number 1. And it is located 1111 million light years away. Okay, so if you will scroll on down in your lab to that first set of charts, you will see that there is a place where you can put this information. Okay, so go down to the first set of data tables, and the first one says Galaxy ID, and so you're going to put in 1 for the Galaxy ID. Okay, now the next thing is the distance in mega light years. So you would just put 1111. So 1111, 1111 for your distance. Okay, now the next thing, so let's go back up into the lab. Okay, it says the hydrogen spectrum for that galaxy and a reference hydrogen spectrum as measured in the laboratory appear below the field of view. Okay, so if we look over here, this top set of lines is going to be the spectrum of hydrogen. Hydrogen has a red line, it has a bluish green line, it has a blue line, and then it has a purple line. Those were the 4 colors for the emission spectrum of hydrogen. Underneath it is the same spectrum. So notice you still got the red one and the green one and the bluish one and then the purple one, but you notice that they've been shifted. They have been shifted towards the red end of the spectrum. So remember in your electromagnetic spectrum chart that radio is on this side over here, and then on this side was the gammas. So you got your Roy, G, Biv, those are the colors of light, and so this color has shifted more towards the red end of the spectrum. And notice that this green one has shifted more towards the red end of the spectrum. So each of the different emission colors has been shifted a little bit. It's going to be your job to try to measure how much each of those lines has been shifted. It says to click on one of the spectral lines. So I'm going to click on the red one. Okay, and notice here's the red one that we had before. So this red one right here is this red one right here. But notice that the other red one is gone. See this red one? It's missing. That's because it's been shifted so much that it's over here somewhere. It's been shifted into the infrared part of the spectrum. So that means that if you go down to the data table, so let's go back down to the data table now, and it says for the red line, so down there at the bottom, it says for red which has a rest wavelength of 656.28 nanometers. We cannot calculate the Doppler shift. So you would just put NA in that box where it says Doppler shift delta lambda. For red, you're going to put NA for not applicable because it's been shifted completely off the scale. And then likewise, you can also put NA for the next column where it says the red shift Z, because if you don't have a red shift, then you can't have, if you don't have a shift, you can't have a red shift. So put NA for that one as well. Okay, now let's try it for another color. All right, so I'm going to put the cursor on that red line and I'm going to click it, and then I go back to my regular spectrum. So this time I'm going to do it for the green one. So I'm going to click on the green one, and now notice that this time I've got a green line over here and I've got a green line over here. So this time I can measure the change in the wavelength. Now there is a misprint in the lab though. So the misprint is that it's saying that the distance from here, from one of these large lines to the next large line, is 0.5 nanometers. That's incorrect. It's really the distance from one of these really small little tick marks to the next tick mark. That's what the 0.5 nanometers is. So it's kind of mislabeled on the lab. So what we're going to need to do is you're going to need a calculator, and you're going to need to calculate how far in nanometers it is all the way across. So notice that we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 full boxes. 10 full boxes. So 10, and then each box is going to be 2.5 nanometers, because there is 1, 2, 3, 4, 5 little boxes inside the big box, and each of the little boxes is 0.5, so 5 times 0.5 is 2.5. So if you've got 10 big boxes, then that would be 10 times 2.5, which would be 25. All right, so that's 25 nanometers from here over to here. But we still have 1, 2, 3, 4 little boxes. And since each one of those is 0.5, 4 times 0.5 is going to be 2. So 2 plus 25 is 27. So you're going to put 27 as the Doppler shift delta lambda for green. So put that in that box in the data table. Okay, so let's go ahead and do the indigo one. So just so that you see how to do this, we're going to do the indigo one. So I'm going to click on the green one, and so now I go back to my original spectrum, and now I'm going to go to this one, and I'm going to click on it. Okay, now how many boxes? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So you're going to have 9 boxes times 2.5. Whatever that number turns out to be, I don't have my calculator with me. Plus 1, 2, 3. So you had 3 of the 0.5s. So 3 times 0.5 is 1.5, and then add that to that other number that I told you to calculate. And you would put that down for indigo. Well, I am not going to do this for all of these galaxies. So what I am going to do is I'm going to use the data that one of the other groups did in lab, and I'm going to give you that data, and then you're going to work on it, okay? So I'm going to pause the video right here, and then when we come back, I'm going to tell you the data that the other group got.